Hey everyone, thanks to those of you that are joining. It's not super crazy important. Unlike last year, I'm not going to be super interactive with the demo, so you can look at your neighbor, but if you do want to have it in your own hands, feel free to join that, and that'll come up in a couple of minutes. So let me just set some context first. So what I'm going to be talking about today is something that's been a problem for me. It's a nut that I've been trying to crack for almost a year now. And let me kind of pitch the problem to you first. So here's an Elm map. I'm sure many of you immediately recognize this with its beautiful type-safe boundaries. And you know, this made me really happy learning Elm, given the kind of history and programming that I'd had, and the guarantees that we had within Elm, which I'm not going to rehash, but this is within a particular app, right? So when you're working in your environment and you compile your stuff and then you ship your app out, that's the experience that we have. However, then you make changes, and there's a new version of your app, and there's another new version of your app. And at the same time, perhaps you're dealing with a server, and there's the same picture there. That server might have another new version, and if we expand this out a little bit and we think about those transitions, initially there might be a transition from the first version of your app to the second version of your app, but then that might also happen with the third, and then you've got a consideration, well, if your app is talking with a server, that could happen, but those deployments might not be synchronized, so maybe you deploy a server, and that's at different times to the app. So maybe you've got a new version of your front-end app that needs to talk to an older version of your server, or maybe you've got an older version of your app that needs to talk to a new version of the server. And this kind of becomes quite overwhelming to think about holistically. So I've been working on various angles here. As Evan always says, like, code is the easy part, so I thought, great, I'm going to go write a bunch of code, because that's the easy part. That turned out to be a terrible idea. But in any case, a bunch of stuff is shaken out over 12 months, and what I want to talk to you guys about today is a vision of what it could look like to focus on just this part of the problem and see what happens. Now, when I'm drawing these arrows, what I'm actually talking about more concretely is talking about that state that's moving across. So not specifically the code and retaining that code, but it's this idea that we have an app and it's fully functioning, and then when we deploy stuff, by default in Elm, we don't have anything to help us along here, right? There's no connection there. So here's a photo of an Elm app in the real world. As again, you've probably all recognized, this is here in the winter of deployment, where it's kind of lost all its state, quite literally. Hopefully soon we'll move into the summer of statefulness. But this is kind of like sad, because you know, it's just got nothing on it, and there's snow, and it's cold. I grew up in Australia. We have a lot of evergreen trees, so trees that don't lose their leaves. And in our backyard growing up, we had this tree that every year would, you know, turn its leaves color and literally drop its state on the floor. And it was kind of like, why, tree? Like, you don't need to do this to yourself. There's beautiful evergreens. You know, they keep their leaves on throughout all seasons, regardless of what happens. And you know, there are small changes. You know, pines and leaves fall off here and there, but they kind of regrow and they shapeshift. So I wanted to maybe start by inspiring a vision of what this could look like. This is a proof of concept demo. So if you want to pull up the pres.live apps on whatever device you have, and I'm just going to quickly explain what's going to happen, and then we'll kind of step through it. So we're going to write an Elm app. We're going to work at Profit Corp, where we're going to release this new app. It's a counter, and the counter only goes up like our profits will, to show everybody how amazing it's going to be to invest in our company. So we're going to release the first version, and then we're going to make some changes, and we're going to do another version. It's going to result in another application that we need to deploy, and then we're going to result in a third set of changes, and we're going to deploy those out to users too. And what hopefully we'll see is that the state that our users have on the first one, right, all the profits that our users increment that they're definitely going to receive, we want to make sure that we retain those each time we deploy a new application. Cool. All right, so this is going to be the first app. So here we've written our counter, and of course we've used a float. The profits require precision, and our text is going to be some text, a message that we're going to send out to our users. So let's go over to our app. Ooh, where's the mouse? Somewhere here. Okay, and I'm going to hit a button, and hopefully that's going to deploy a bunch of stuff to everybody. Okay. So red, green, blue, RGB, just think of that as the first version. So you should all, yes, has people got the first version? You've got red on your screens? Excellent. So make sure that you start increasing your profits immediately. Oh no, what's happening? We have too much precision. Okay, so let's go back and fix this bug. So what we're going to do is we're going to, we're going to change this to an integer, right? We need to fix this bug in our app, so we're going to go and change our type. The Elm compiler is going to complain. We're going to go through the rest of the app, fix all the bits, right? And so now we have this version of the app, and so let's go and deploy that with any luck. So I'm going to push a new version to all your phones. Yes, we got green? Excellent. So hopefully you haven't lost your profits. So do make sure to keep rising those profits faster than all the people next to you. Excellent. But now our marketing team's come back and they said, oh, actually green is the color of our competitor. Also, like, this message is kind of, you know, it's not really that nice of a message. Let's go and make another couple of changes. And what we want to do this time is, it's really long for the uptake. We want to change our message to actually be message. I mean, the team internally also had an argument about nomenclature, and we're going to set a new value there. So again, going back, let's see if we can upgrade one last time. And now we have our nice new corporate blue. So again, hopefully you've retained your state through this. So we've seen 3 completely separate application deployments, and everything's kind of transitioned all the way through. Okay. All right, so I'm going to run through quickly how could this work. There's lots of possible ways that we could do this. I'm going to run through maybe at a high level the kind of key things that we need and how you could do this in Elm today just using Elm. So there's 2 kind of main problems to get this working. One is passing state between apps, so getting the same state the user had into the new app. And then the second part of it is kind of upgrading that state into the new set of types that we have in the new app, right? So let's deal with both of those one by one. So the first thing, reading state between apps. This is kind of roughly the idea of what we have state 1, and then there's some magic, and then we have state 1 in the new application. And you can see the blue bounds are our kind of type safety bounds. Well, one way we could do this today is we could use ports. And so in between, we have some sort of interchange format, probably a string with some stuff in it. And there's two question marks on either side. So what could these be? Well, here we've got state going to a string, and here we've got string going to a state. And a bunch of you have probably thought, encoders, decoders, yes, that's what we want. Well, actually, let's think about that for a second. If we think about, these are not all of the Elm types exhaustively, but some of the ones that I work with most commonly. And then if we think about JSON encoders and decoders, we don't actually get coverage, not at least in a native representation, right? So immediately we get ourselves into the realm where we have to say, well, thinking about a union type, how are we going to represent that in JSON? Well, the question is, if we're thinking about how we're going to represent something in a format, then we could think about maybe not using that format or using some other format entirely. We've got, you know, half our work cut out for us anyway. So there's a kind of nice article by Evan here that you can look up that talks about a bunch of different questions that kind of need to be asked if we're thinking about general data interchange formats. But I kind of just wanted to pick out this one particular line, which is kind of noting there's a bunch of difficult questions, right, for data interchange as a whole. But it's not about picking a format, but rather picking a format that can evolve as your application evolves. So let's page it back a little bit and think about our specific problem and the kind of properties that we would want here. And these are the ones that I would propose. First, we need this to be general. Ideally, anything that we put in our state, any sort of type that we use from Elm, we would like to be able to then get back at some other point with a couple of exceptions for types that don't make sense, such as functions. We'd want this to be versioned. Maybe in the future, we will find a more efficient or a faster or more compact way to kind of store this and be able to retrieve it back. So we'd like to be able to change that. I think we'd like this to be a black box. So we're not actually dealing with a data interchange format. We're kind of dealing with an identity function. We want to put stuff in there, and we kind of want to get it back. But we don't want third parties reading in and out of this box behind the scenes. And I think the combination of first three means that this can actually be automatic, which I think would be really important for the developer experience, that you don't have to go and write some sort of encoder and decoder for every single type change you make, but that's something that can happen automatically and in a closed way. So if we go back and look at that diagram, we're kind of taking a set of elements here, and we're going to encapsulate them, and that's the first part of Evergreen. So that is the kind of first step checked off. So let's think about how to go from state 1 to state 2. So the premise is we've got some sort of type with a value there, another type with a value there, and we need to get from one to the other, then we get from one to the other. Hey, functions. We might call this function migrate, and there we go. Now we have a type signature for what we want. So a quick reminder, here's how our type evolved across the three applications that you guys just saw. So originally started with a counter and text, then we modified that to an int, and then we renamed a field to a message. So what would these migration functions look like? Well, actually quite straightforward. So if we're migrating from 1 to 2, we're just creating a new object, which is going to be state 2. State 1 has been passed in, so for the text, we simply use a text. That type hasn't changed. But for our float counter, we need to choose what we do. In this case, I've chosen to round. You might choose to floor it. You might choose to concretely set a value. That would be up to you. In the second set of migrations, we're going from 2 to 3. Again, this time our counter type hasn't changed, so we can just set it again. And our message in this case, marketing has said, well, let's force all users to see the new hello value. Cool. So bringing it back to the first part. So in the first part, we were able to get state 1 across as state 1, but application 2 operates on state 2. So what we actually want to do is patch in that new migration function that we've written, and thus we've managed to get all the way around to state 2, solving that second part. Cool. So we've gotten to the point where technically it seems like this kind of makes sense, and we've got type safety all the way through as well, which is really nice. The result of this actually turns out to be some really, really nice properties. There's a bunch of other problems that happen when you start considering migrating between applications. It was really interesting to find how some of the properties that Elm has are already kind of conducive to making these problems not be there, and I think that'd be really, really difficult outside of the context of Elm. The first one I'd like to kind of run through quickly is asynchronous message handling. So you can imagine we've got an application, it's been running, a whole bunch of things have been happening, and maybe one of those things that's been happening is we've sent out some sort of command that will give us back a type of message one. So maybe we've sent a HTTP request, we don't know when it'll come back, maybe we've asked for a random value or who knows what. And so there's a bit of a race condition here where maybe as we fire that request, we're also upgrading, we've released a new version of our fantastic app, and our state has kind of gone across to application 2, and at some later point, maybe that message returns. Now, the problem that we have here is that this message type is from our original application. It's not message 2, so we can't, it doesn't really make sense to put in here. I mean, we could cram it in and hope that the message types haven't changed, but that's not really that nice. So what could we do instead? Well, let's consider the same scenario. State 1 has gone through to state 2, and we've got that command still pending, potentially. Well, actually, we can use exactly the same mechanism. Remember, one of the properties that we defined for our kind of black box evergreen encoder was that it was general, so it was able to encode types of any type that are within Elm. So we receive that message 1 back, and then in the same way, we have encoders and decoders generated for those messages. We run them through Evergreen, and then we can upgrade them in a sense. And again, those migration functions that we saw we wrote that handling explicitly. You could have that same control in that way. So sometimes maybe it makes sense to upgrade those. So in the applications that you guys played with, the increment message was always migrated from increment message 1 to increment message 2. It made sense for increments to still be passed through. But maybe sometimes it won't make sense. If you've removed a particular message type or changed it fundamentally, then you would match that, you would upgrade that to maybe like a no-op message and have a dedicated message in your application that kind of does nothing. That's really nice. Another thing is caching and state restore to some extent. So if we consider the fact that we were able to go into the box and send state 1 to another application, so state 1, in the same way we can send state 1 back to ourselves. So if you think about it from the perspective of an app that's booting up, you know, I'm a brand new application and I've been deployed into production and I'm ready to go, and I get given kind of my state string. I don't know whether that state string was given to me because we're currently upgrading, or whether it was given to me because we might have restored it from somewhere. So we might have this concept of a cache. Sometimes it might make sense to have this. Maybe we have a little counter app where it's not too important, and then maybe sometimes it might not. But in any case, the expansion is exactly the same. We still have our encoder and a decoder, except this time it's coming back to our own application. So again, that was nice and almost trivially free to add because of Elm's architecture. Then my favorite one, multi-version state handling. So consider we've written an app, and we've got, this is the very first application, right? So our init function is basically setting everybody's state. And then we release a new version, we release a new version, we release a new version, release another new version. And every single time as we're doing these versions, whenever there's a significant type change, we've got these migrations, and they can all kind of be linked together. So what then do we do when we have a user appear with state 1? Well, we can identify what state they've come in with, and then we simply put them into the migration chain at the point that they've come in at. So, you know, maybe they've turned the app off, they've been away for a couple of weeks, we've deployed lots of awesome new versions, they kind of come back, and you can kind of think of it like a slippery dip. They kind of go in there and they slide all the way down and then they pop out. Same thing again, if we simultaneously get another user come in with state 3, we also know how to deal with them. So over a long period of time, you might be thinking, well, we're accumulating a lot of migrations here. What do we do when we want to drop them? Turns out that's also really easy as well. Dropping migrations are actually the same as the starting point. The first slide that I showed you, you don't know whether there were any migrations before that at some point, you just know that was the initial point. So we can simply drop a bunch of them and move our initialization function to the first point that it makes sense. So now if we get a user coming in with state 1, we don't know what state 1 is. It's either too old, or it's corrupted, or there's, you know, they've tried to fiddle with it, or whatever it might be. And so for them, they simply get the normal initialization, and they get the normal app like as if they were a fresh user from scratch. And so the really exciting thing about this is that the migrations are always type checked. How many of you have used Rails and maybe active record migrations? Cool. How many of you had the experience where you've accidentally or maybe intentionally used classes and then later someone's removed a class and now your migrations are broken? Yeah, there's a couple of hands. So kind of for free, we get Elm's guarantees across the whole system, which means you can use any code from your normal application, and then at some point, if you remove that code and your application breaks, you'll know exactly where it's breaking and why, and you make a choice. Do you move that code into the migration or keep it somewhere else? So I thought that was really, really nice for a problem that I've seen before with this. Cool. But wait, there's more to be done, unfortunately. There's a really big question here that wasn't apparent to me immediately when I started this. I kind of thought if you solve the technical part, obviously that would be awesome and everyone would use it and it'd be great. But actually when you start trying to put this together, there's a lot of much larger questions which I think deserve a lot of time and thought against to hash out. So we've got the tooling that you've seen that exists, but let's think about actually using it. So you're working in your app. Think about your production app today. You've just installed Evergreen. You're super excited. You're just going to have all this stuff for free now. You make a bunch of changes to your types. Your Elm code's compiling. And then something happens. I'm not sure. And then we deploy and everything's great. So that's something, there's a lot of different ways we could approach that, all the way from you literally manually writing everything, which I think would be very, very painful. Like the cost versus benefit might not be exactly what we want there, to having automated tooling or having integrated workflows or editor integrations, I'm not sure. So there's a bunch of ideas that we've been trying out around this. But to give you some kind of more context to the kind of questions, what if you want to roll back a change that's not yet been deployed? Say you're working with pull requests, you're working for a couple of weeks on a big feature, you've changed lots and lots of types, but now you want to change something, but you've not deployed it yet. What does that mean? What does that look like in a linear way? What if you want quick development changes without migrating writing migrations for each change, right? So maybe you're prototyping something, like Richard was showing in his talk before, like things might evolve in the design stage, but maybe you still want to be loading your app while you're doing that, but not necessarily having to write those. What happens then? And then maybe even more consensuously, what if you're working in a team and somebody else on the main line has already changed the types and you've changed them too? As far as Git is concerned, maybe you have no merge conflicts, so those changes would come in nicely together, but then the app as a whole doesn't make sense anymore, or the semantics have changed. So I think they're all questions that potentially have a lot more thinking to do. On the other side of the coin, thinking about what does a great user experience look like. So for all of you here, I got to cheat. I chose exactly the delivery mode, taking into account where we are and how the network works. But should a new version be sent to the user like immediately or at some point later, or should we ask them? What if they're on a mobile connection and data is expensive? Like there's some considerations there. Should they get to choose when they upgrade? So say we've shipped them the app, how drastically is that app going to change? Would they want to see release notes? Would they be shocked by the kind of changes that we're putting in front of them? So what do we do about that? And again, what happens if the user is on an extremely old version? Are they going to be happy with silently just losing all of the state that they've had in there before? Say you were building a wrapped Elm application that you were shipping onto mobile phones, either as a progressive web app or as a wrapped app. What do you do in that scenario? Do you message them? What works best? So they're all really open questions that I think probably, like I said, worth spending a lot of time thinking about in more detail. Okay, so what's next? Well, for us, I think it's important to finish and refine the automatic codec generation. So the stuff that you played with was already initial version. We've gotten fairly far. But I think the main thing that this unlocks is being able to think deeply about the developer workflow. Once that generation is kind of there, we can think about, okay, how can we put this into the development cycle? How does it feel to use it? When should it trigger? What does it cost us in terms of mental overheads to our normal workflow? And yeah, there's going to be lots of different things here to try, so there'll be a lot of feedback that we need to get on that side, which leads into getting more feedback from the community on use cases. Like I said, this is for me a personal problem that I'm trying to solve for myself. Maybe some of you don't have that problem, or maybe you have solved that problem in other ways. It's still very possible that I'm missing a bunch of information, so we're really keen to get that feedback back from you guys as well. So yeah, finishing up then. You can get in touch, so a big thank you to Philip, who's worked on a ton of this stuff with me and helped me prep this talk. But yeah, either us on Elmlang Slack is probably the best way to go. I've added our avatars so you can find us visually. And yeah, if there's something that excites you especially, or that you can think of use cases or even things that I've missed in this talk, I'd really love to hear from you. So yeah, thank you very much.